A very good morning to everyone. I am G. Naresh from ECA section, IARA College. My Tech Talk topic is about SR flip-flop with logic diagram. Let's get into the topic. What is a flip-flop? A flip-flop is a term which comes under digital electronics, and it is an electronic component which is used to store one single bit of information. A flip-flop is used to store a single bit of information at one time. Since flip-flop is a sequential circuit, so its input is based upon two parameters. One is the current input and other is the output from previous state. It has two outputs. Both are complement of each other. It may be in one of two stable states, either 0 or 1. The flip-flop is completely depends upon the output of a flip-flop is completely depends upon the current input and the previous output. SR flip-flop. What is a SR flip-flop? It is a flip-flop with two inputs. One is S and other is R. S here stands for set and R stands for reset. So that S set and reset SR flip-flop is totally abbreviated as set and reset flip-flop. The SR flip-flop, also known as set reset flip-flop or the SR latch. Set basically indicates set the flip-flop, which means the output 1, and reset indicates resetting the flip-flop, which means the output 0. When the output is 1, it is called as set mode, and when the output of the flip-flop is 0, then it is called as reset. Here, clock pulse is supplied to operate this flip-flop, hence it is clocked flip-flop. Construction of SR flip-flop. We can construct SR flip-flop with two ways. One is with two NOR gates and two AND gates, and the other is by using 4 NAND gates. So we can construct the SR flip-flop by two NOR gates and two AND gates, and in the other way we can construct with 4 NAND gates. Let's see the construction of two NOR gates and two AND gates. First, here S and R are taken as inputs, and clock is the other input for both of the AND gates first. Then this AND gates output goes into the NOR gates, and the other inputs of the NOR gate is for the first NOR gate. The other input is taken from the output, that is Q bar, and for the second NOR gate, the other input is taken from the output of the first NOR gate, that is Q. These NOR gates combinedly known as NOR latch. So the SR flip-flop by NOR latch is shown in the figure. And the construction of SR flip-flop by using 4 NAND gates. Here totally NAND gates are used. It is also similar way, that is, first the inputs set and reset are taken, and E means enable, that is the clock pulse. These two inputs are given to the two NAND gates separately, and then the outputs of this first and second NAND gates will given to the let it be R bar and S bar. They are given to the other NAND gates, and the output of the third NAND gate is taken from the Q bar, and input of the fourth NAND gate is taken from the Q. This third and fourth NAND gates are combinedly known as SR latch. So the ultimate outputs are Q and Q bar, which is complement of the output Q. Basic block diagram of SR flip-flop. The basic block diagram contains S and R inputs, and between them is clock pulse Q, and Q bar is the complemented outputs. Here, as we discussing about the basic block diagram, first it is a sequential circuit with two inputs and two outputs. The two inputs are set and reset along with a clock pulse, and the two outputs are Q and Q bar, which are complement to each other. And the working of SOR flip-flop. The working of SOR flip-flop includes four cases. Case 1, let's say S equals to 0 and R equals to 0. That means both the set and reset conditions are low. Then the outputs of both AND gates will be 0, and the value of Q and Q bar will be same as the previous value, that is hold state. In the case 2, let's say set equals to 0 and reset equals to 1. Then the output of both AND gates will be 1 and 0 correspondingly. The values of Q will be 0 as one of the input is 1 and it is NOR gate, so it will ultimately give 0. Hence Q gets 0 value. Similarly, Q bar will be complement of the Q, so that it will be 1. And in the third case is when S equals to 1 and R equals to 0, then the output of both AND gates will be 0. Here, when S equals to 1 and R equals to 0, then the output of the both AND gates will be 0 and 1 correspondingly, and the value of Q bar will be 0 as if one of the input of the NOR gate is 1. So output will be 0 ultimately, and this 0 value will go to the input to upper NOR gate, and then hence here Q bar will be 0 and then the Q bar 0, and the output of the AND gate is given to the first NOR gate, then the output will become 1. It is a third case. And the last and final fourth case is that, let's say both the set and reset inputs of the SOR flip-flop is high, that is 1, then the output of both AND gates will be 1 and 1, which is invalid, as the output should be complement of each other. Here, when S and R both are 1s, then the AND gates will get 1 and 1, which is invalid. Then the AND gates output will get 1 and 1, which is invalid, and the NOR gate condition fails here, so that we should get the outputs complement of each other. Hence this is not satisfying, so that this condition will be invalid condition. Truth table. The truth table of the SOR flip-flop. Here S is the set input and R is the reset input. Qn plus 1 is the next state, and state tells in which state it enters. So in this truth table, S is the set and R is the reset, as we have discussed previously. Qn plus 1 is the next state, and the Qn plus 1 is the next state, and state tells in which state it enters. So as we discussed previously, when the set and reset are zeros, then the output will be Qn and it will be in the hold state, and when the reset is high and set is low, then the output will be 0 and hence it is reset condition. And when the set is high and reset is low, then the output will be logical 1, and then the state is in the set state. And the fourth case is that when both are the set and reset conditions are high, then the outputs are 1 and the hence the output is invalid and it will goes to the invalid state or undetermined state. Applications of SOR flip-flop. There are numerous applications of SOR flip-flop in digital system which are listed below. The main applications of SOR flip-flop are registers, counters, memory and synchronous systems. Registers. SOR flip-flop used to create registers. Designers can create any size of register by combining SOR flip-flop. Registers are formed by group of flip-flops. Counters. SOR flip-flop used in counters. Counters counts the number of events that occurs in the digital system. Counters are used to count the number of clock pulses in the system. Memory. SOR flip-flop used to create memory which are used to store data when the power is turned off. And the last application is synchronous system. SOR flip-flop are used in synchronous system which are used to synchronize the operation of different components. Conclusion. The SOR flip-flop or set reset flip-flop is a fundamental digital circuit used in electronics and digital systems. It has two inputs, set and reset, and two outputs, Q and Q bar, which are complement. And when S is set to 1 and R is set to 0, the output Q becomes 1. Conversely, when S is 0 and R is 1, output Q becomes 0. In other cases, when both the inputs are 0 or both the inputs are 1s, the flip-flop behavior is undefined. SOR flip-flop are used for memory storage, data synchronization, and control signal generation. However, they have the potential for undesirable states, making them less popular than other flip-flops types like D or JK flip-flops, which address these issues. Thank you.